Hello, everyone. Thank you for joining us today. My name is Scott Sugden, Product and Technology Manager here at L-Acoustics. I'm glad you could join us for today's presentation all about L-ISA. So today we're going to talk about L-ISA, how it works, why we want to use it, and what we've been doing over the last couple of years. I brought along with me a really great panel of experts to help answer questions throughout this presentation. I want to introduce them because it's some of the best we've had yet to date on a panel here or a webinar here at L-Acoustics. Starting with my neighbor here just down the road, Carlos Mosquera. Carlos, how are you today, my friend?
Hi, Scott. I'm good. Thank you for inviting me. I also can answer questions in Spanish. Entonces, amigos, si tienen alguna pregunta, me dicen y con gusto la responderé.
And Carlos, you're an application engineer specifically working in the L-ISA team, and you've got a wealth of experience and knowledge. You've been involved in some of the tours around the world on L-ISA, and you help to educate as well as develop some of the tools that we use on L-ISA every day, correct?
That's correct, Scott. Thank you.
Excellent. Thank you, Carlos. Let's head a little bit east to London. None other than the Sylvain. How are you, sir, today?
I'm good, thank you.
Sylvain, and this is your first time joining us on a webinar. Sylvain, you are a L-ISA Labs engineer specifically in London. You work hand in hand with the R&D team, helping to develop these tools and produce content, correct?
Yes.
Excellent. And Sylvain, you can help answer some questions for us. English, French, anything else?
No. Just English and Francais. Necessary.
Excellent. I love the background, by the way. It looks like you're on a vacation somewhere in Tahiti. Is that where you are?
I don't know, but yeah, probably. No, it looks like France, by the way.
Okay, got it. Okay. Excellent. Well, thank you for joining us, Sylvain. And let's hop to Sergey. Sergey, I miss your brick wall, but it looks like there's a new feature in our webinar presentation here. So thank you for joining us, Sergey.
Hello, everyone. Really glad to join. Привет всем.
Excellent. And heading a little further east, Tommy, how are you, my friend?
I'm good. Thanks for invitation, Scott. So I think I need to talk now about the weather. I don't have that great background here, so it's just my office background. I'm so sorry for it, but that's the difference between the guys from London and from poor Berlin. Hallo da draußen, also falls ihr Fragen auf Deutsch habt, könnt ihr die auch gerne auf Deutsch stellen und wir freuen uns, dass ihr wieder eingeschaltet habt heute zur großen L-ISA-Show, zur Einführung von L-ISA. Scott, up to you.
Thank you, sir. Thank you very much. So everyone, thank you for joining us today as we talk about L-ISA. It's a really, I think, important story for our industry. It's a really important to think about where we're going, the future of sound, right? So before we actually talk about the future of sound, I actually think it's important that we go back in time a little bit. And what we need to do is think about where our industry comes from. So L-ISA is a story that has its roots way back 50, 60 years ago, in that we think about how we do live shows. And the reference for me, the benchmark for me, the real indicator for me is a series of events or shows in the 1960s. It's the Beatles coming to America. And why I bring this up is this is the first time that our industry was challenged to do shows on an enormous scale. How do we do sound for 50 or 60,000 people in places that aren't naturally meant for concerts? Before this point, we were doing shows in theaters. We were doing shows in opera halls, in places that are designed for acoustics and not in these stadiums or festivals or entirely new places. And if you've ever heard about these shows or read about these since then, you'll know one thing. They were really exciting to be at, albeit nobody heard the show, right? And it starts to make sense when you look at this picture. You see a bunch of people on a stage in the middle of the stadium, and there's not much equipment around them that you would typically expect to see. In fact, they were using speakers that weren't designed for throwing audio 50, 60, 70, 80 meters and trying to overcome the noise level of 55,000 screaming teenage girls. So let's think about the state-of-the-art technology in the 1960s. In the 1960s, if you were mixing a live show, you were fortunate enough to have 12 or maybe 16 inputs, right? So you could pick your favorite 12 or 16 things and that was it. So you only had a few channels of audio to work with. In the 1960s, you were lucky to have 100 watts, maybe 150 watts per amplifier. And if we talk about our watt per kilogram ratio, it was probably pretty close to 1-to-1, right? So that amplifier was very large, very heavy, and didn't produce much power. In the 1960s, speakers that were used at these concerts were column speakers that were more often seen in train stations and cathedrals than they were in concert venues. And this is what they were trying to use to throw the audio to the back of the venue. It wasn't quite enough power to do what we were trying to do. And by the 1960s, the state-of-the-art music format is the stereo vinyl record. So state-of-the-art mixing, you have 12 inputs. State-of-the-art amplification, you have 100 watts per amplifier, maybe 150. State-of-the-art speakers are skinny and tall like the Beatles, and of course, stereo vinyl records. If we fast forward a bit, by the 1980s, we've increased the quantity of everything, right? So now we have 40 or 50 inputs on a mixing board. You can arguably mix an entire orchestra with 40 or 50 inputs. Amplifiers now have 1,000 watts each, and maybe it's a 10 or 15 or 50 or 100 watts per kilogram. It's much more reasonable. Speaker systems now can be arrayed very large, right? So we can talk about arrays that are 8 wide and 6 tall, and they produce more than enough sound pressure level to get over the screaming girls at a concert. And of course, we can carry more music in our pocket than ever before. So instead of a large vinyl record, we can use a small compact disc for that stereo 74 minutes of stereo audio. So by the 1980s, we've increased the quantity of everything. We're making everything better in terms of quantity. And we fast forward again, let's go ahead another 20 years or so to today, and we now have digital mixing boards with hundreds of inputs, with sample rates that are well and above what we can discern as a difference, with the ability to add processing on every single channel, whether that's an equalizer, a compressor, a gate. We can add effects, so we're not just mixing the basic audio channels, but we can add all kinds of effects. Today we have amplifiers like this L-Acoustics AVB. It's almost 40,000 watts of power in a rack that's not a whole lot bigger than the amplifier was in the 1960s, and it probably doesn't weigh much more than that amplifier did in the 1960s. So in the 1960s we had 100 or 150 watts. Now we have 40,000 in something that's not a whole lot different in size. We have speaker systems that can produce sound over audiences of tens of thousands of people. It can do this without destructive interference like the array of the 1980s. It can evenly distribute that sound for all those people and get loud enough to make a concert experience even 70, 80, 90, or 100 meters away. And of course, today's state-of-the-art music format and player is your portable device, right? It's your iPhone or Android smartphone, your iPod, if you will. And we're listening to stereo, just like we've done for the last 50 or 60 years. So over the last 50 or 60 years, we've evolved all the technology that transmits the audio from the artist on stage to the audience's ears. We've improved the quality of microphones, of snake systems, of consoles, of amplifiers, of loudspeakers. We're arraying them ever better than ever before. We're optimizing every last component along the way. The only thing we haven't touched is the format. And if we start to look at this format of a live concert experience, we see a big stereo system. This happens to be the main stage of the Coachella Arts and Music Festival in Indio, California. Right, this is one of the largest music festivals in the world, and this is one of the largest PA hangs of K1, K2 you can deploy. This is 24 enclosures per side. K1 has more SPL per meter than anything else on the market, so it can throw further. It's full range. It goes down to 35 hertz on its own, so we don't even need hardly any subwoofer to get full range music out of it. But how stereo is it? Right? How much of your mix that you put in this giant stereo sound system is actually stereo? So let's think about that for a second. Where do you set the pan on your kick drum? Right? It's probably right in the center. Where do you set the pan on your snare? Where do you set the pan on the bass guitar? Where do you set the pan on your lead vocal? Where do you set the pan on pretty much everything that's musically important in your mix? And ultimately, everything that's musically important in your mix is set to pan center because you want to put it in the center of your mix and distribute it evenly to everyone in the audience. So the reality is that giant stereo PA is actually dual mono. So let's think about the second question. We've got a giant dual mono PA, right? So our lead vocal is now in the middle of our mix, which means it's coming out equally from both sides of this giant PA. So who localizes that to the center where we intend it to be? Well, really, it's only the people right in the middle. In fact, if you're slightly to the left or slightly to the right, you don't localize that person where you intend them to be as a mixing engineer. You don't localize them to where they are. You perceive it to whatever speaker you hear first. So I hear that left speaker first. It turns out everything that's panned mono, which is most everything important, comes from the left speaker, not from the middle of my mix. What about separation? How do we separate different musical elements, right? Today we separate it with compression, equalization, and amplitude, right? And let's think about how challenging that is. This is just a nice little graph of all the different musical instruments that might be in an orchestra or a band, and we see that there's a huge amount of overlap of the frequency range each instrument plays. And so the challenge you have as a mixing engineer is finding the amplitude difference between all of these different musical elements. Finding the dynamic difference between all of these different musical elements. You're using tools that modify their space or their sound so you can find space for them in your mix. I think it'd be a lot easier if we just had more space in our mix. Let's think about intelligibility. Every part of that dual mono mix, if you're in the venue where you hear both left and right, or the main mix and the side hang and so on and so forth, you're introducing a comb filter on all those critically important parts of your mix. We know this. We can hear this really clearly with, for instance, the bass guitar that comes out of the left and right PA. As you walk across the venue, you introduce a big comb filter that causes shifts in tonality and can interrupt and disturb intelligibility because of the time offset and the comb filter introduced. Right, so everything that's dual mono is going to have that comb filter for everyone in the audience that isn't sitting perfectly dead center, which is pretty much nobody. How immersive is it, right? Let's take a look at this. The video wall here at the Coachella Music and Arts Festival is close to 100 meters wide. The PA is not. Right, so we're not taking the same kind of landscape, the same kind of space. How big is that feel? So L-ISA, what's the goal here? We want to have more full range sources as opposed to just left and right. The goal is to have more full range sources so we can have natural separation of the music elements. I don't want to try to separate them with a compressor, with an equalizer, beyond what I need to make them sound correct. I want to separate them physically or geographically. And this becomes easier to distinguish different musical elements. So let's think about the different ways we can think about this. It's a lot easier to distinguish those musical elements when they're coming from different places. It's no different than the sound of an orchestra in the orchestra hall. You can localize or hear where they're coming from versus the sound of an orchestra on your stereo recording. We also get much better localization accuracy because we see and hear them come from a similar or the same place. And when we have this audio-visual fusion, we get a nice spatial coherence, and it's more enjoyable as an audience member and less fatiguing. You don't have to use a certain percentage of your brain power to connect what you see and what you hear. When you look and I see that guitar solo and I hear that guitar solo from the same place, it's much more connected than when I see the guitar player dancing across the stage yet the sound is coming from a speaker off in the distance. So for this to work, there are three parts that we need to think about. We have to have a proper sound design. No ifs, ands, or buts about it. We need to have some processing to convert our traditional way of mixing into this new way of thinking. And we need an intuitive and elegant way to control this mix so that the art can lead, not the process. Let's start by talking about the design. So we need a way to design a sound system to cover the audience in this new way. We need to be aware of what speakers are covering what people. And for that, of course, at L-Acoustics, we have Sound Vision, which is an advanced 3D modeler. And we can model complex venues. This is the Hollywood Bowl, for example, in Los Angeles. And this is a 3D model of the entire bowl, the entire audience, including the visual obstructions that will be produced by the lighting tower positions. And here we can model the SPL, the sound pressure level across the audience. It's quite important. We can also take a look at the coverage, so we can see what speakers covering where. We can take a look at the temporal response, or the time response over the audience, so I can figure out what delays need to be added and what delay times need to be added. I can even look at the spectral response, or the different responses across the audience, to make sure that we have a consistent spectrum across the audience as well. Within Sound Vision, we have developed some tools specifically for modeling L-ISA. These tools allow us to quantify and qualify how many people in the audience are going to get this improved experience as an audience. So what we can actually do is figure out who gets to hear this entire new way of mixing and who doesn't. And this allows us to determine where we need to place fill systems. We can check to make sure that the audience has enough, the sound system has enough power to cover the audience for a given program type. We can look at the SPL distribution across the audience. So this is all developed within Sound Vision, so before you even get to the show, you can quantify and qualify that L-ISA sound design. So an L-ISA design, what is it? What do you need? What don't you need? Well, it can be a very complex system, but they all start with the same thing, a very simple L-ISA Hyperreal sound design of 5 or more full range sources representing the scene. So the scene is that space that has the action. Think of it as the stage on a concert. And that scene starts with 5 or more full range sources. Where those sources overlap, so what we want to do is figure out where most of those sources overlap, or all of those sources overlap. That's what we call the spatialized zone. And our goal now is to get as many people to hear all 5 of those speakers as humanly possible. We can enhance that panorama. So we can make that panorama larger than just the scene itself, and that's by adding some extensions. And those extensions, once again, try to cover the same area as the scene. And for everyone sitting in that spatialized zone, they can hear the entire scene and the extensions. And now our audio landscape is even larger than the visual landscape with just a couple of extra speakers. We've talked about over the last several weeks in these webinars the different possible placement and style and deployments of subwoofers. And everyone would agree the best choice is a single mono subwoofer stack. However, that's really hard to time align with a left-right system. But it actually works out pretty well with an L-ISA sound system. So we have a central subwoofer deployment flown adjacent, above, or behind that scene system when possible. And we have an automatic mix generated to inform or put the correct mix information into that subwoofer stack. So with most installations of any type, you're not going to be able to cover every single seat in the audience every single time from your main sound system. So L-ISA sound design has the ability to develop front fills, out fills, under balconies, so on and so forth. And we can place those and design those as needed to get the coverage for the people that are in more difficult areas. We also have the ability to have surround speakers. So we can add surrounds in the horizontal dimension. We can also add overheads in multiple layers above the audience as well. So there's no limit to the number of layers you'd like to have of overheads, or no limit to the number of channels, as long as you have outputs in that L-ISA processor. So let's talk about step 2. So once we've done the sound design, we need to start thinking about how we process the audio, and this is where the L-ISA processor comes into play. So what is the L-ISA processor? The L-ISA processor is a low latency multi-core architecture designed specifically for rendering the L-ISA algorithms within this new way of thinking and this new way of mixing. It has 96 inputs, so we can take 96 channels from our desk and convert that to 96 objects in L-ISA. And what you're going to think about a bit differently is how to mix the show. This is done via MADI, So the L-ISA processor has 3 input MADI streams to connect up to 96 inputs at 96K. Each one of those inputs or objects can have a different pan. We can enhance that dimension of pan with a function called width, where we can make an object take up space in your mix without affecting its tonality. We can apply distance and make it sound further or closer away. Or of course, we can also pan or add elevation in that other dimension. As I said, it's 96 kilohertz, so this is 96 inputs at 96K, and we can have up to 64 outputs. So L-ISA processor can do 96 inputs and up to 64 outputs. It has an integrated patent-pending room engine as well. What's really neat about this room engine specifically, it takes into account the size of the venue, where you've placed the speakers, to ensure that the reverb always arrives after the original signal, no matter where the original signal is in your room, and no matter where you are, the listener in the room. So what's really neat about this is if you have an object on the stage, the direct sound will emanate from the stage, and the reverb will follow. The L-ISA processor has been designed from day one to be redundant capable as well. So for mission critical events like live shows, we can have 2 processors running in parallel to ensure that there's full redundancy and reliability. So step 1, all about the design, ensuring that the speaker coverage is as good as possible for a given venue. We have that processor to convert those channels of audio that you've always had into objects so you can dynamically control them throughout your mix. To do that, we have the L-ISA controller. And this gives us direct control of every single L-ISA object, all 96 of those input parameters, whether they're a mono input or a stereo. Stereo could be that stereo keyboard input. And you can choose your pan, you can choose your width, you can choose your distance, you can choose your elevation independently for all 96. To make your life easier, you can enable groups as well. So for instance, you can create a group of drums, and that group of drums can be panned. You can also apply pan spread to that group, spread out that group or make it smaller. You can apply distance and width to each one of those objects as a group as well. The L-ISA controller has an integrated snapshot engine, so you can save snapshots within the L-ISA controller ecosystem, and these snapshots can control obviously every parameter of every single object, and has the ability to function via with a crossfade time, has the ability to trigger from MIDI timecode or MIDI program change or OSC as well. So the L-ISA controller is also our gateway for external controllers. External controllers could be a plugin. We have a plugin written specifically for digital audio workstations. And that plugin controls mono, stereo, or groups of channels, of objects. And that works in all the popular digital audio workstations like Pro Tools, Ableton, Nuendo, Reaper. We have the ability to externally control with OSC. So with OSC, we can use QLab, we can use Touch OSC, we can use Max to create new and interesting and dynamic interactions with any object in the L-ISA ecosystem. We can even interact with trackers. So we can use tracking solutions to automatically position an object within the sound space. So that means an actor walking across the stage can be automatically positioned both in X, Y, and even Z if desired. And these trackers integrate natively within L-Acoustics, the L-ISA controller, pardon me. And last but not least, we want you guys to mix differently, right? I want to think about how I mix in a new way, but I want to continue to use the platform that I've been used to using over the last 10 or 15 years. So we've developed what's known as DeskLink. And in DeskLink, for instance, on a Digico or a Yamaha PM Rivage console, you can actually interact with all of the parameters of the L-ISA controller for each object as well. So you can see the pan of that specific object on the same channel strip that you have your compressor, your gate, your EQ. So you don't even have to go over and use the L-ISA controller. You can use that Digico or Yamaha console. We've got a plugin specifically developed for the Avid SXL series that allows you to have control of these parameters via the plugin architecture of the Avid SXL. So over the last few years, we've done a number of events with L-ISA, from orchestral music like the BBC Proms. The entire run of the BBC Proms at Royal Albert Hall has been produced and enjoyed via L-ISA. Ennio Morricone's tour across Europe was with L-ISA as well. And we've done really great events across the world in the United States, in Australia, in Europe, combining movie with orchestra music. So the live orchestra playing the score, for instance, of Harry Potter in Australia. We've been on tour with some of the biggest acts around the world, from Bon Iver to Mark Knopfler, to Christine and the Queens, to Lorde, to Childish Gambino, playing arenas from 10 to 15,000 people, day in, day out, with L-ISA systems up to size of 9.1, 9 arrays across the front, for audiences enjoying this every single night. We've got installs in Russia at the Mercury Tower. We've got a project with Aerosmith in Las Vegas. Their residency is presented to you in L-ISA. And a really great venue that traditionally performs about 6 nights a week in London, which is known as Earth, has a fully immersive hyperreal L-ISA sound system. So it's arrays in the front, sides, behind, and even overhead. We've done festivals, from classical music in Austria to a small music festival in a town called Boom at Tomorrowland, with even a really interesting festival with electronic music in Thailand called Wonderfruit. So we've been at a number of festivals with L-ISA where artists are creating new and unique experiences for their audience. We've done special events with DJs, electronic music, with modern musicians like Molecule, with Deadmau5 and Alt-J, for fully immersive, hyperreal events at stadium size with Alt-J, or a live video event for Deadmau5 in Los Angeles, a live broadcast on Tidal that was produced in the audience for L-ISA, and DJ Molecule, who's producing live events in Paris with 1,500 people in a fully immersive environment with him in the middle. So this presentation today, guys, is all about an introduction to L-ISA. Tomorrow, we are talking about how to do your loudspeaker system design. I think there's been a few questions specifically about array overlap. It's a very different feeling to think this way, of having your arrays overlap. So if you're interested to learn more about why we're doing that, how we do that, that's going to be all about tomorrow's presentation as well. Next thing as well, we have on Wednesday a presentation about pardon me, on Thursday, a presentation all about mixing in L-ISA. So we're going to talk much more detail about object-oriented mixing. If you guys have any questions right now I can help answer, please feed them into the moderators, and I'll do my best to answer those today. But tomorrow is going to be all about loudspeaker system design, and Friday is going to be Thursday is going to be all about the mixing environment. Friday, we actually have a conversation with 2 pros who have been using L-ISA for the last couple of years. That's Scott Wilsalem and Fred Vogler. So we're going to have a conversation with Scott and Fred and myself, including Sharif, who's the Egyptian magician himself, one of the first people in Team L-ISA here at L-Acoustics. So please don't hesitate to join us when it comes to that. Did we have any questions coming in? Let's see. I think I see one about overlapping arrays. I think we're going to talk mostly about that tomorrow. Sergey, did we have any questions coming in on your end at all?
I think I answered most of them. Let me check the new ones. I don't think we have any more questions, and I think that we will cover more stuff on the webinars later this week.
Excellent. I think then that is close to the end for this. If there aren't any other questions coming in, I'll give it one more minute to see if anything pops in that we cannot answer or won't be answering in the next couple of days. So tomorrow we're going to talk all about the design. We're going to talk about spacing of arrays, the number of arrays, how you determine the overlap of coverage. We're going to talk about placement of extensions and surrounds. Thursday is going to be a big conversation about how you mix, how you interact with all these objects, how you apply parameters, snapshots, and I'm sure we'll have more coming forward after that. So thank you guys very much for joining us today. Please don't hesitate to join us tomorrow. We're going to have a lot more information tomorrow and Thursday, and a great conversation on Friday with Guillaume, Sharif, Scott, and Fred and myself. Have a great rest of your day. If we don't see any other questions coming in, I think we're done. Thank you guys very much. We'll see you soon.